Lesson 4.6, Fit a line to data. What this means is that we're going to learn how to write equations of lines that represent actual data where paired information has been plotted. We've talked before about a scatter plot, and a scatter plot is simply a graph that's used to determine the relationship in paired data. And they can also tell us trends, or we can use them to predict future values of the quantities represented in the relationship. A positive correlation is just like positive slope. If the path of the dots is upward, we have a positive correlation. Negative correlation, again, relates to slope. If the path of the dots is downward, we have a negative correlation. Then the third possibility is no pattern at all, and we refer to that as relatively no correlation, but for our purposes we'll typically say just no correlation instead of the entire term. You'll be asked to describe the correlation in data graphed a lot, and sometimes you'll have to graph it yourself, and sometimes the graph will be given for you. In this example 1, we're asked to describe the correlation of the data graphed. Well, clearly, if you drew a line, and when you draw these lines, you should be using a straight edge tool. So we want to draw a line through these dots. That one's okay. Notice how there's more dots underneath. We want to do a little better than that, so you want to try to hit right through the middle, and I'm doing it again, so there we go. That's a good line. See how there's about as many above and below? You just want to have a line that most closely matches the path that the dots are taking. But it's pretty obvious in either case that the line that we end up with for comparing the hours of studying to the test scores is positive correlation, as explained in the textbook answer. And for this one, B, where we compare the hours of television watched to the test scores, the more time we spend in front of the TV, the lower our test scores become. And again, negative correlation, which corresponds to what the book says. So let's practice now that we know how to do it. Tell whether X and Y show a positive correlation, negative correlation, or relatively no correlation. And the way to do that is simply to think of using a paintbrush to follow the path of the dots that you see. So let's try it now. If we used a paintbrush to go through these lines, again, you want your lines to be straight. So let's go with a straight line. That's a pretty tight correlation because you can almost cover the lines or cover the dots with one line. But now when we go to the second graph, we don't really have that same pattern. There's no line. When you try to figure out where to draw your ruler, there isn't one. So this would be no correlation, where this was positive correlation. Then we come to our third picture, and this one appears to be a line, so we want to grab our straight edge again before we tackle this one. And we draw the line down through it. Clearly, we have a case of negative correlation. For this one, number 4, again, when you see a line, grab a ruler, draw your line. And obviously when we draw the line here, negative. And I'll abbreviate since I'm running out of room, I'm writing too big. Again, on the next one, we see positive correlation in a line. So we grab our straight edge to draw that line, and then label this one positive. And for the final one here, again, there's no straight edge that's going to predict what these are doing, so we would say no correlation for that one. In guided practice, number 1, we're asked to use The scatter plot's an example 1 to predict a reasonable test score for 4.5 hours of studying and 5.5 hours of television watched. Let's go back and look at those graphs from the example. Well, this is kind of like the example we did in class the other day. At 4.5, you would go, notice that we're counting up by ones, so between 4 and 6, that would be 5, so I'm going to go halfway between those, and right through here would be where we're looking. And if you look at that line, not very well drawn, but gives us a good idea of what we're talking about, then we want to match up where the intersection hits the y-axis, and we're somewhere in the vicinity of 70. So let's make 70 our prediction for that one. And if we come over here to 4.5 on the hours of watching TV, that looks a little bit like 75. So, not sure I have much faith in these graphs, but that's how you use the graph to predict. In guided practice number 2, we're asked to make a scatter plot of the data in the table and then describe the correlation. So this is where we have to produce our own graph. And we plot these just as we always do, noticing that the top row is X and the bottom row is Y. So our first point is the point 1, 2. So we're going to go to the right one, and I've set up a scale on the bottom to take 2 steps for 1, so or 2 boxes in the graph paper. So I go over 1 and up 2, would put me there. Then I go over 1, and we can check them off as we go. Over 1, up 3, put me here. And then 2, 4, we're going to go to the right 2 and up 1, 2, 3, 4 would put me there. And then to the right 3, up 4, we go here and line up with the last point I made. And then to the right 3, up 5, I'm going to go up 1 from the last one I made. To the right 4, up 5 would be here, lined up with the last one I made. And then to the right 5, up 5, we start all over here and line up with the last 2 we made. It's an interesting little pattern. To the right 5 and up 7, we're going to go to here and make a dot. And then to the right 6 and up 8 would put me here. So once again, you want to look at the overall trend that we see. And let's pick a really light yellow and go with a paintbrush here to help us see the path. If you tried to run through those dots, that's about what you would see, but definitely positive correlation. Well, these lines that we've been drawing to kind of see what the correlation is kind of lead us towards the next concept, which is the line of fit. And a line of fit is where it ties back to what we've been doing throughout the chapter in writing equations and such. A line of fit is simply a line that fits the path of the points in a scatter plot. So we won't do all 6 of these. I don't think we need to as examples, although they would be good practice for you if you want to try it when you pause the video. But let's look at number 7. And our directions say, draw a line of fit for the scatter plot and write the equation of that line. So we'll do that because we can. We're pretty good at writing equations of lines by now, I hope. Alright, so our first step is to draw the line. And again, if we're going to draw a line, we want a straight edge. So grab your straight edge and draw the line. That's where my line's going to be. So we're going to write its equation now. And I'm going to write it right here on top of 10. So what do we need to know for an equation of a line? We need a point. So we're going to look for points where the line we drew crosses the grid lines on the graph paper. So that looks like one right there at 1, 1. And then the next one I see is way back over here at -1, -4. How do we write an equation of a line if we have 2 points? You should know the answer to that by now. First thing we're going to need is the slope. So we do m equals bar minus minus. Let's put the 1 in first. Remember the y on top, it's x underneath it. And we're going to put this other point, y on top, it's x underneath it. And the top and the bottom here, we have a minus negative situation where they cancel. 1 plus 4 is 5. 1 plus 1 is 2. So our slope is 5/2. Well, now that we have our slope and 2 points to choose from, we're ready to use point-slope form. And we're going to fill in our blanks. 5/2, the slope always goes in front of x. And we're going to use 1, 1 because it's all positive and nice and friendly to use. So there's the point-slope form of this line. And to put it in slope-intercept, remember we need y by itself, so let's work on that. I'll switch colors and see if that runs together. Not quite as bad. So we're going to distribute the 5/2 first. The 5/2 is positive, so when it distributes, it's not going to change any of our minuses and pluses. So we're going to keep the minus, and 5/2 times 1 is 5/2. Well, we've still got the y minus 1 over here, so we have to get rid of this minus 1, which we do by tossing it to the other side. And when we do, we still only have one x term, so that's going straight into our answer box. But then when we bring that minus 1 over here, remember it's plus 1. And if you grab your calculator and do negative 5/2 plus 1, you should get minus 3/2. And if you look at it, that pretty well matches our picture, because remember in this form, this is my y-intercept, and look, it tells us right about where that line hits the y-axis, which is a good sign. And that's pretty much it. Stop and do your homework.